Okay, well, good morning. Here we go. We're going to kick off with 7-3. Before we do that, give you a glimpse of more coffee, enjoying the morning. I hope you guys are all doing well. Let's play a little bit of Christmas music. Get you back in the mindset of Mr. Bennett's classroom, and hopefully we get to go back to school next week. But you never know. So, at any rate, okay, well, let's pause that. Now, let's get after 7-3. You need to have your notes out. Triangle inequality theorem is what we're talking about. And we got some homework at the end of this lesson. So, here we go. Here's the triangle inequality theorem. You can follow along in your book because I'm pretty much going through that. But I'm hitting the highlights of things that I know that you need to know. Okay? Triangle inequality theorem. The sum of any two sides of a triangle must be greater than the third side. The sum of any two sides of the triangle. If it's not greater than the third side, then it's not a triangle. Okay? So if it's not greater, then it's not a triangle. All right, well, so if we're going to try and determine then, what is the measure, if we look at page 345, your turn, what's the measure possibility of x? Could x equal 2? No, it can't, because 2 plus 14 is not greater than 21. Because that's what would have to be true. Sorry, 21. And we know that 2 plus 14 is 16, and that's not greater than 21. So no, x cannot be 2. So here's a little, shortcut or way to look at it. Add them and subtract them. This will find the range. This will find the range. Now, range is kind of an interesting word, but mathematically, back in 4th or 5th grade, we found the range, and the range is the distance between two numbers. Okay, and so if I want to find the range of possibilities, what can x equal? I know it can equal 2. How about 0? No. How about 10? Well, maybe. If I use 10 plus 14 is 24. That's greater than 21. 10 plus 21 is 31. That's greater than 14. And then 21 plus 14 added together is greater than... All right, so 10 would work. But we don't want to just kind of guess and check like that. There's a better way. And this is how. You add them and you subtract them. So you go 21 plus 14, and that's equal to 35. So it has to be less than that. Because if I would think, just bear with me here, what if I would say 36? Is 21 and 14 added together, does that give me something larger than, greater than, not equal to, can't be equal to, has to be greater than. The third side, is that greater than 36? No, it's 35. So it has to be less than 35. Remember, points to the left means less than. So, quick review there. Left, less than. Points to the right, greater than. You always read it from left to right. Okay? All right, so back here, so we know that has to be less than 35, and that's when I added them. Now let's subtract them. 21 minus 14. Remember, add them and subtract them. 21 minus 14 is 7. So that means it's got to be greater than 7. What if I tried 6? Let's just do a little test. How about 6? 6 plus 14 is 20. That's not greater than 21. What about 7? 7 plus 14 is 21. That's not greater than 21. What about 8 or 9? Yeah, or 7.1. So my range would have to be that x has to be between 7, so it has to be greater than 7, and 35 has to be greater than x, and so x is in between those. I could write that inequality statement like this. 7 has to be less than x, which has to be less than 35. Sometimes that freaks students out. But basically, it's got to have x in between those two numbers. Okay? All right, good. Let's keep moving. Let's do another example, give you a little bit more practice. We're going to add them and subtract them. So here we go. Let's use a different color pen on this one. So I have x, 9, and 18. Let's add them together. X plus 9 is 27. So x has to be less than 27. Okay, so let's just do a test. What if x is 26? Let's see if that works. 26 plus 9, yeah, that's greater than 18. 18 plus 9 is 27, that's greater than 26. 26 plus 18, yeah, that's a lot larger than 9. So yeah, that's a possible inequality that would make the value of x appropriate for the third side of the triangle. Okay, now let's subtract them. 18 minus 9, and we get 9, so x has to be greater than 9. All right, let's test it. What about 10? 10 plus 9 is 18. Yep, that works. What about 8? 8 plus 9 is 17. That's not greater than 18. So the sum of any two sides of a triangle must be greater than the third side. So here's my inequality statement. Again, 26 is greater than x, which is greater than 9. Or the other way around, you could say 9 is less than x, which is less than 26. So either one of these would work. Okay, that's 9 and 10. All right, let's move on. That's a triangle inequality theorem. Can't get much simpler. Just add or subtract them to find the range. Now, let's talk about side angle relationships. And this is kind of interesting. This is something I know I've referred to in the classroom before, but this is something that you need to make a note of. Okay, so again, this needs to be in your notes somewhere. This is the longest side. Oh, this is me saying it. There's a theorem, but we're not going to write that in your notes. This is me kind of giving you the best way to recall this. When we're thinking of triangles, okay, so side angle relationships, I should say, within triangles. Okay? All right, so within triangles, the longest side is always, sorry for that, is always across from the largest angle. The longest side is always across from the largest angle. Think of a right triangle. If I think of a right triangle, if this is 90, and let's say that this is 40, and this angle's right there is 50, right there, that one's 50, and this one's 40. Okay? Which one's the largest angle? Yep, the 90. So which one's the longest side? Yep, hypotenuse. It always is in a right triangle. Hypotenuse is always the largest. Okay, and so conversely, it's also true that the largest angle is always across from the longest side. And the same thing is true. In fact, you can put them in order. The shortest side is always across from the smallest angle. So you can order the lengths of sides and the measures of the angles appropriately by how they're compared with each other. Longest side, largest angle. Smallest side, or smallest angle, shortest side. All right, let's take a look. Let's take a look at your turn, page 346, number 11. All right, so here are my three sides. Which one's the largest? Of course, 40. If we're going to put these in order, 40 is greater than 32, which is greater than 15. Pretty obvious there. And so then we have to look at what side is opposite 40. I'm sorry, what angle is opposite 40, which is angle C. So it'd be angle C, that's opposite 40. What angle is opposite 32? Which is angle B. And then what angle is opposite 15? That would be angle A. And so those are the, in order from greatest to least, the angles based on the sides of the triangle. Okay? All right, let's do another one. All right, which one's the longest side? 25, so that means that the angle opposite, so we got room over here. Angle A then would have to be the greatest, or the largest angle. The next one is 24, so we'll go opposite. That's greater than angle C. And the next one is 7, we'll go opposite or across, and that's greater than angle B. So there's our inequality statement. And as I said, the same thing is true conversely. Let's take a look at it. What if they give you the measures of the angles? Is it the same thing across? Yes, it is. If I look at 160, what's the side opposite? That would be AB. greater than 15 or 5? Well, it's 15. What's the one opposite of 15? That would be AC. And then the last one, of course, would be BC. Now, sometimes you can just look at it and it seems obvious. BC looks like the shortest side. Do we know what the lengths of them are? We don't. We're just ordering them. We're just putting them in order from greatest to smallest, or greatest to least. Okay, all right, let's do the last one. Well, this symbol right here tells me that it's 90 degrees, so the side opposite would be AB, and then that is greater than the side opposite, the 60, which is BC, and then the side opposite, the 30, which is AC. All right. Those are the relationships, and here's your assignment. 5 through 20, page 348, except for number 15. That's it. Due tomorrow. Today's Tuesday, so due Wednesday at midnight. What's the date of that? I should write that in there. Today's what, the 8th? Yeah. 9/9/12/9/2020. All right, everybody. Have a good day. If you have any questions, email me. Take care.